cylinder and prism formulas come from for surface area, and first I probably will try to show you where surface area comes from, and we could even show where the formula comes from. So if we have a box like this and we were to break it down, let's say it's a cube for the base, a square, and then not a cube but a square base and a height of 10. And we want to sort of pay close attention to this part up here. So when we break it down, we're going to have a front, a back, the left side, the right side, and then the top and the bottom. And as you notice, this top here is the one I marked red. And when we cut out each face and folded them flat like this, we can remember that these four pieces are touching the base. So the idea of surface area is the area of all the surfaces on the shape, which would mean the top, the bottom area, the front, the back, the left, and the right. So if we wanted to, we could find this area by breaking it down as we just did and finding and adding all the areas. So the top of the base would be 4 and 4. That would be an area of 16. And the other one would be 4 and 4, which is another 16. So it's really 2 times the 16 because we have two bases, the area of two bases. So we're going to see as part of our formula, we're going to have 2 capital B, which stands for the area of the bases. Then we're going to add the other 4 pieces. So if the other 4 pieces have a height of 10, each one has a width of 4. So the area of each would be 40, 40, 40, and 40. 4 times 10 is the area of one of them. There's 4 of them. So we would add this 160 to it. So our total surface area is 160. But rather than pull them into 4 pieces, what we could actually do is make this one large rectangle. And in doing that, we can find the area of that rectangle. So what numbers do we use to get that? We have 4 here, and 4 here, which gives us 16. The total on the bottom or the top of the big blue rectangle is 16. And we can see now if we get the area that way, the area of a rectangle, it's 16 times 10, which is how we get our 160. So the way we can actually describe that is it's the height of the shape is 10 times the 4 plus 4 plus 4 plus 4 times the 16. And if we remember, the 4 here, here, and here were touching the top of the base. So we can actually get this by adding the 4 pieces of the base. 4 plus 4 plus 4 plus 4. So we can actually create the second part of this formula, or the second part of the area, this part, by multiplying the perimeter of the base, that 4 plus 4 plus 4 plus 4, which will give us 16. So that's where we get the capital P in the formula for surface area. We're going to get 2 times the capital B, which stands for the area of the base, the shape of the base. And then the perimeter of the base is what capital P stands for, times the height of the shape, of the original shape. So if we can remember that the P stands for perimeter, but not just perimeter, but perimeter of the base, and that the capital B stands for not just area, because there's many shapes, but area of the base, we can actually apply this to prisms and cylinders. So other prisms will work the same way. We can get the area of the base times 2 plus the perimeter of the base times the height. Now this will work in multiple shapes. You know, we could make a triangular prism and we can get the area of the base, which is this triangle, 2 of the areas, plus the perimeter of that base, the perimeter of this triangle, times the height of the prism. We can use any shape, we could use a hexagonal prism. Any prisms, this surface area formula will work. So let's take a look at what it looks like in a cylinder, because we'll just have to remember that in a cylinder, P, or perimeter, in a cylinder is going to be the same thing as circumference. So circumference is the perimeter of a circle, the circular part. And so we use the word circumference, but really it's a form of perimeter. And if we do that, we can just learn this one formula: 2 area of the bases plus perimeter of the base times the height. So when we take a quick look at a cylinder, it'll look like this. So the surface area would be to cut this apart, and we would actually, if we cut it down the height, when we roll it open, it'll form a rectangle. And then there's going to be a top and a bottom base, a circle. So we'll use the same formula, right? There's 2 bases we get the area of, because we want the surface area. Area of 2 bases plus the perimeter of the top. So when I unraveled this, I'll use green. This top piece, when I cut it, we want to remember that this part on top was touching it. It went around that circle to form the cylinder. So we know that the height would be here, and we know the radius is here. So right when we find the formula for area of the base, we'll have to remember the area of a circle is pi r squared. And then the second thing we'll want to remember, like I mentioned, is that perimeter of the base. Now that we see which perimeter it is, it's the perimeter of this circle. So we'll be reminded that perimeter is circumference, so 2r pi, or 2 pi r, times the height of the shape. So we can memorize this formula or use the general one and just remember what is the area of a circle and what is the circumference of a circle. I know most people use 2 pi r, but my class decided they would write it in the order that you plug it in. 2 times the radius times pi. So the circumference right here is 2r pi. Right? So let's say we take this without the formula and find the surface area. Well, like we just showed, it's going to be the exact same thing. There's a base here, a circle, and a base here. The area is pi r squared. And then the height is here. So to get the area of this rectangle, we do 2r pi, which is the top part that used to be wrapped around the circle, times height. So surface area can be used in a formula, or we can, if we forget the formula, we can actually do what we did and make a net. Flatten it out in 2 dimensions and get the area of each piece and add the areas up together. So that's where the surface area formula comes from, and how we'll take another video to show how we can use it and apply it to find the surface area. So the surface area is in prisms and in even a cylinder. If we remember what perimeter of a cylinder is, it's a circumference, we can use this same formula: 2 times area of the base, the shape that we consider the base, plus capital P, which is the perimeter of the base, times the height of the shape. Now we want to remember, when we have a cylinder or a prism, when we have a base, what we would consider the base is 2 shapes that are the same shape, and the height separates them, and they're parallel. The 2 bases must be parallel. So that's why when I lay a triangle down like this, and sometimes students want to say, well, the base is the bottom. That's a rectangle. No, base is not bottom. We don't always think of that as bottom anymore. Base, in this case, there's 2 triangles. They're parallel to each other in 3D, and the height is considered how far apart they are from each other. So we have a new way of looking at base and height compared to middle school, where we just said base means bottom, like when we did base times height in a triangle. Here we have on top and on the bottom, they're the same shape, they're parallel, and the height is the distance between them, but in a rectangular or square prism, we can use this and this as a base because they are also parallel to each other, they're the same shape, and the height would be how far apart they are. Now, one last thing as a reminder that I'm sure many of you know, whenever we get a triangle's area and we say it's 1/2 base times height, just like the height in 3D just now, we said, the height has to be really perpendicular to the bases. So if the base here is the rectangle on top and the bottom, the height is perpendicular to it in 3D. Likewise, if this is a base, in a triangle, the height has to be 90 degrees or perpendicular to it. So a base and a height are perpendicular to each other. If the triangle was like this, the base and height are 90. And if the triangle is not, if it's more tilted over, this could be our base. Our height, again, would have to have the amount that is perpendicular to the base. So the height would be like that. So that is what the idea of surface area is. It's the area of all the surfaces. This is where we get the formula from. And in another video, we'll do some practice problems.